Now I will explain how to simulate amplitude modulation using Multisim. The circuit for this is this is a circuit diagram. So this is a carrier signal. Carrier signal is I can set 50 nodes peak to peak. 11 kilohertz is a carrier frequency, is always high frequency, and the message signal is 2 volts peak to peak, and frequency you can set as 1 kilohertz. And you have to voltage divided by S is 6.8k and 22k, and you can choose PC107 common emitter NPN transistor, and capacitor you can choose 0.01 microfarad and L as 130 millihenry, and emitter resistance is 10 kilo ohm. So I'll rig up the circuit. So double click on the tool. So you're going to get a new design. Okay, so you can see how to pick the components. I'll show you. So you can just redo it. So first you have to get uh, one transistor. So the transistor you can get it from place component. Okay, place component. Go to place component and go to all groups and all families. Otherwise, if we have transistor directly, if you type, you'll get. So I want BC107. To type here BC component BC107. If you type BC107 directly from all groups and all families, you can directly get this symbol. So click OK. You click OK and place here. Okay. After that, we have to keep this voltage signal source. So this you can get. Go to sources. Go to place component. Okay, place component. The group you select sources. Under that, you click on signal voltage sources. Select AC voltage. We want AC voltage. So this is the symbol you are going to get. Click OK. Or directly, what you can do is go to all sources, all families. Type AC voltage. You will get. I'll show you. Place component. If you know that component is present in which source, which group, you can type it. Otherwise, what you can do is just go to all groups and all families. Okay, there you type. Just now we type PC107. Similarly, you type AC voltage. Okay, AC current is there. AC voltage source you have to select. So this, if you click OK, you'll get 2 times you have to place it. Okay, 2 times you have to place it. Once you place it, double click on it and change the voltage value to 50 volts and frequency to 10 kilohertz. Change this value and this value. Click OK. Okay, and similarly another voltage source you have to keep here, and you have to change that values to 2 volts peak to peak and frequency as 1 kilohertz. Okay, after that, how much? Four, I think, 1 2 3 3 resistors you have to pick. Go to place component and select resistors. This is there in the basic group. So in the basic group, resistor is there. You can select 1k only by default, and in order to rotate vertically, press Ctrl R. So 3 resistors you keep and double click on it and change the values. You can change the value to any desired value. Okay, yes, 622k is there. Similarly, this resistor, you have to double click and change it to 6.8k, and this one more resistor, you have to double click. And so in order to rotate the component, you have to select that component and Control R. Okay, after that, two components L and C you have to place here. So you have to go to place component basic. Okay, then select inductor and capacitor. So here is same, it is already there in the group. So select capacitor, click OK like this. Then if you want to rotate, so like that, we want vertical direction, you place here. Once you place, double click and similarly you place inductor. So that also you have to rotate. So like this. So this is, I'm just showing how to place. After that, double click on that and change the values. So 1 microfarad you can change it to any value. So if you want micro, you have to click OK, U button. Yeah, U key you have to press. For nano, you have to click N. So here it is 1 millihenry and 10 nanofarad. So now you have to make the connection. So I'll just show how to do the connection. Okay, I'll do fast connection. Okay, so to place that to place this VCC, you have to go to place component, then sources. Go to sources, then DC power sources. Here VCC or VDD, you have to select VCC. Click OK. By default, 5 volts will be there. Okay, you can change it to any voltage. Here it is already showing 12 volts, so no need to change anything. It is 12 volts only. So I will show the connection once again. So what are the components you have to pick? Everything I'll show you. So these are the components. You have to place all these components. So go to place component and place all these values. Okay, see here, these are the discrete components. Okay, so now I will do the connection of all. Okay, so I pick a place component, first place transistor, 3 resistors, okay, and 1 inductor, 1 capacitor, 4 resistors actually, here one more is there, and 2 AC voltage source, and 1 oscilloscope. Oscilloscope you have to select here from the right edge. So 4 channel oscilloscope. So now I'll do the rig up. Once you place all these components, now first join these two. From here you join this. From here you join this. So from here you go down and go up. Click here once and then go up. Then wherever you want to turn, click there using mouse click and come down. So from this you have to short here. So this is parallel path connection. You have to click here, then go up. Click here, go up. And this is actually junction. Here junction should come. So I'm clicking here and stop here. And again from here, come and stop here. Don't directly connect here to R1. Here node will not come. So if you zoom it, you'll get one dot here. You can see that. So you can see here. You can see here. This dot should come. Okay. Okay. Now okay. Now remaining connections are from this power source you connect here, and from this you connect here, and this you connect here. After that output 4 channels here I picked here because we want to do 4 actually we want to see one output on the input. We want to see one first. I want to see the carrier, so I will place one carrier, one channel to carrier here. So I want to see the carrier waveform. I want to see the message signal. So if you don't want, if you able click somewhere here, so here this much gap should be there in order to connect. Then I want to see the output. Output is taken from the collector. Okay, you can observe here no connection directly. This channel A is connected to here. Now I'll check this channel C. I'll connect to channel collector here. So I'll connect here only. Okay, I will change the colors of all. So message signal I'll give uh, red color only or pink color. After that, then this carrier I'll change this one to blue color. Then output I'll give it to green color, dark green. So double click on it or right click on that and select segment color, or double click on that and you can do it. So now let us see the definition of AM. So AM is actually the process of changing the amplitude of the carrier in accordance with the modulating signal transmitted and keeping frequency and phase of the carrier constant, unchanged. Okay, that is actually amplitude modulation. Amplitude of carrier is actually going to modify accordance to amplitude of modulating signal or message signal, and we have to keep frequency and phase of the carrier unchanged. So now I will show the simulation output. Now circuit everything is over. Okay, so this one is connected to VCC and I think ground is also connected. So now all the connections are ready. So now you can see the output. The expected output you can see in the AM. I'll show the expected output. So this is the carrier signal, which is high frequency. This is the message signal or modulating signal. After modulation, you are going to get, see the amplitude of the carrier. See, the amplitude of the carrier is wherever modulating signal is increasing, the amplitudes also keep modified according to this. So these portions are removed, and whenever it goes down, okay, its amplitude, this portion, the amplitudes are reduced. So here reduced, here retained. So this much is retained and these are actually removed. The amplitude are actually altered or varied in accordance with amplitude of modulating signal. So this is the amplitude modulation, and in amplitude modulation, modulation index is given by AM by AC. So that is this voltage, okay, amplitude of modulating signal AM by amplitude of carrier AC. So modulation index is AM by AC. So the range of modulation index is actually 0 to 1. So 0 means no modulation, 1 means 100% modulation. I think here it is almost 100% modulation. If it is less, then you may get like this little bit you will get here. So that will show in the simulation. So let us simulate now. So go to, it should be interactive. Okay, this should be interactive. Then click run button. After clicking run button, okay, double click on here. So you are going to get all these waveforms. So now you have to vary this. So I'll change. This is actually if you are using 4 channel. Channel 1, if you want to select one channel 1, you have to click on this. This point is pointed to A. If you want to channel B, the channel 1 is connected to which one? So let us see. Channel 1 is connected to, I think, channel 1 is connected to channel A is connected to carrier. Channel B is connected to modulating signal. Channel C is connected to output. So double click on this. Channel 1, channel A is connected to carrier. So carrier, now I will change this one to division. I will increase the 2 volts per division to, I will change this one to for 20 volts per division. Channel A, click on A, change this one to 20 volt per division. Now if you want to see in opposite color, click reverse. We'll set blue color now. So now in order to see, so this I'll keep at the top. Okay, so I'll keep at this top. So increase the offset. Okay, now channel B is actually modulating signal, message signal. So it is actually this one, pink color one is that one, and channel C is output. So channel C you bring down. Okay, offset you bring down so that you can see the output properly. So this I think now increase the scale division, you reduce it. Instead of 20, you reduce this one like this, and this one you keep AC. Channel C you keep it in AC. So now this is the output we are getting. So channel B little bit I will reduce gap. Okay, channel A is this one, message signal. Channel A is I'll reduce. Okay, now we can see all the waveforms. This is modulating signal. So this one channel B, I will change this one to like this. Time division also if you want you can change. Okay, now I will change the value of amplitude. You can see it is this much gap is there. Okay, I'll change the value of, instead of 2 volts I'll change it to 3 volts, 3 or 4. Okay, if you increase the value of amplitude of the message signal, so once you modified it, then you have to stop it and run it. So actually here it's coming as a message signal because I changed the value to, I changed the label I changed it as message signal. By default it will be V1 and V2 will be there. So label, if you want message signal, you have to give message underscore signal, don't give gap, blank you shouldn't give. So message underscore signal, message signal. Similarly for this I named it as label as carrier signal. So this is the output. So now if I run this, so this volt is 4 volts. Similarly you can change the value of this amplitude to 5 volts or 6 volts, anything you can change. So every time if you change, okay, now we can see the difference. It is still coming down now. Okay, so here the carrier is altered according to your the signal. This is actually message signal, and this is the process done in the transmitter. In the transmitter, amplitude modulation will be done. At the receiver, again you have to retrieve this message signal. So how to retrieve again? Actually, I want to transmit this message signal, okay, with the help of carrier. It is actually now transmitted with the antenna. Now, after receiving through receiving antenna, you have to retrieve that original message information. So actually, it is present in the peak. If you observe the peak here, okay, if you observe the peak, you can see here. So now I want to retrieve means for that you have to go for detector circuit. So detector circuit is actually shown here. So if you increase, 1 minute, it is actually going. So this is the demodulator circuit. So the here we are getting amplitude modulated output. We are getting amplitude modulated between this point and this point. Now this, if you give it to detector input, this output if you give it to here, and after that this will detect the peaks of all the waveforms, and you are going to get demodulated original information. So that I already done. That is actually not there in the for you. If you want, you can, those are interested, they can do it. So here I have one more circuit. So first I will stop this circuit. So here I added little bit addition circuit from this point and this. Okay, this is here getting AM wave, amplitude modulated wave is this. Now I will connect this one to detector circuit, peak detector circuit. So then final demodulated output is getting here. Okay. So in this diagram, it is connected to channel number C. So now if you run this, again you can go to place component capacitors, change the value to 0.00 micro. Micro means you have to type a letter U, and place two resistors vertically, 33K and 100K. You have to change by double clicking the value of it, and one diode you have to check. Go to place component, all um, all sources, all families. You type 1BH62. 1BH62, you will get one diode and place it. And after that, the demodulated output you will get here. So now I will run this second circuit. Okay. So which is actually, you can see both amplitude modulated at channel number A here, and demodulated output at channel number C here. So here also 4-channel oscilloscope is used to see one waveform of a carrier modulating signal, amplitude modulated output, and peak detector received output, that is the demodulated original message signal. So I will just run it. So now you can see all the signals are coming here. So change this one to like this, then change this scale to, so channel A is actually the output. Okay, so that blue color. So now first I'll ground all. Okay, if you click ground this one, channel B also you can ground, channel C also you can ground, and channel D also you can ground. All are grounded. Now channel D, instead of ground, I'll click AC and reduce the scale. So this I'll keep carrier, I will keep offset above it. Okay, I will place somewhere here. This is the carrier, around 2 volts above from 0. Here it is placed, carrier. Okay, now output is this. I think channel C is demodulated output. First, let us select this signal. This is modulating signal is V2, that is channel number B. So if it is fourth channel, select B. Again, instead of ground, change it to AC. Okay, let it be like this only. And modulated output is at channel number A modulated wave. It's channel number A. So go to A. So this instead of ground, select AC and change the scale to like this. Now this I will bring down. So offset I will make down. If you click reverse, you'll see this is the amplitude modulated wave, and one more is there, that is actually a demodulated wave. So for that demodulated wave, I will ground anyone. So carrier I don't want because the same signal I have to retrieve back. So now I will cancel this A. Okay. So that is connected to carrier is connected to channel D. Is to channel D. Okay. So D channel I don't want. So D I am grounding. So now this is actually channel number C. So click on channel number C and division you change. So this is actually ground. From ground you have to change this to this. And this offset also, if you bring here, it will detect the peak. It will detect the peak, and this is similar to your message signal. So message signal same frequency is coming green color. If you observe, it is similar to our message signal frequency. So this is the output of modulating signal, message signal after retrieving. So if you increase the offset, actually we are using it is inverted because we are using common emitter transistor configuration. So you're going to get inverted output, but frequency remains same, and that resembles exactly the message signal. Okay, so this is about amplitude modulation.